right, so I hear that the audio cut off on this one, so let's start over on this one. Maybe it was fine on this one, I don't know. It says, to the nearest tenth of a percent, what is the probability that Terrell has more than 3 winning cards? Explain. Well, this would be the probability of more than 3, 4 winning, plus the probability of 5 winning, okay? Or it's the complement of at most 3, okay? Now, if you're the complement, we could say that this is 1 minus the probability of at most 3. And I'll show both ways. So, we're not going to do this one by hand. We're going to use the binomial PDF function, binomial probability distribution formula. If I remember right, he's got 5 tickets. 5 scratch-off tickets, so the number of trials is going to be 5. What's the probability of winning? 30% chance of being a winner, so 0.3. And we're looking for 4 winners, and we're also looking for 5 winners. Now, I don't remember doing these notes before we had the day off, so I don't know if I've talked about binomial PDF at this point in time or not. I really don't. But it is the binomial probability distribution formula in a TI-84, okay? We can get there by hitting second vars, and I'm gonna hit the up arrow because it's quicker, and there she is, binomial probability distribution formula. D is for distribution. There were 5 trials. The probability of success was 3/10, and I'm looking for 4 winners. Enter, enter. Enter, plus, and I'm not going to go back through the process here, that guy changed to a 5. And this isn't too hard to do. You get 0.03078. And let's see here. That's the probability, or if you like percentages, 3.078%. I noticed a handful of y'all still have issues with percentages. I guess some people weren't meant to be doing math. Now, or we have the complement. Now, I mentioned things as though you remember it. The complement of event A, or of probability of event A, is 1 minus the probability of event A. It's everything the first event is not, okay? Now, the at most function can be done using binom cumulative, binom CDF. 1 minus binom CDF. That's called cumulative density function. And what it does is it returns the cumulative sum of everything to the left of the number of trials you get it. So 5. Oh, sorry, we're doing at most 3. 0.3, comma, 3 trials. And this little function I just did, it finds the sum of 0, probability of event 0, through the probability of 3. It adds all of them. It just does it all in one step for you. And we'll get the same exact answer. For 2 things, it's probably not worth messing with the complement event, but it's worth showing. 1 minus second vars, binomial cumulative density function. And we still have 5 trials. The probability of success for any given trial is still 3/10, but here the x value is 3. Same thing, 0.03078. All right, so a test is made of 20 true-false questions. Chris could care less if he passed. He randomly writes true-false. Is this a binomial experiment? For some reason, it's already in there. Yes, it is, because you have an equal chance of getting it right each and every time. And what he guesses on number 19 does not influence how he guesses on the next one. He is blindly guessing. So anyways, what is the probability he gets 5 right? And that is an exactly 5. We can do that with binom PDF. So this isn't exactly. We always use binom PDF. In this case, we have 20 trials. We have a probability of success of 1/2 or 5/10, And we want to know the odds of him getting exactly 5 right. Now, I guess I'm being lazy here. Second vars, hit that up arrow till you see binomial probability distribution formula. There were 20 trials. The probability of success was 50%. And we want to know if he gets exactly 5 right. Enter, enter. 0.0148. Or 1.48%. Now that's getting exactly right. That's not getting 5 or more. All right, what is the probability that he gets 19 right? This would be the probability of 19 plus the probability of 20. Or it is the complement of at most 18, which is how I'm going to do this. So I'm going to do 1 minus binom CDF, 20.5, 18. Because that's the quickest way to do it. And I've already done a CDF operation earlier, so I'm going to go up and highlight that text, press enter. 20 trials. Oop, I got rid of my comma. Comma, 0.5, comma, 18. So really tiny number. We got 4 zeros in front of that 2. Equal to 0.00002. And I'm too tired to remember the rest of that. 0.003, let's say 0.003. Or if you like percentages, 0.002003%. Very unlikely, because remember, bro is just guessing. All right, and there's other ways of doing this problem, by the way. All right, what's the probability he gets more than 5 right? Okay, so if I did this along the way, this would be the probability of 5 plus probability of 6 plus the probability of 7 plus ... the probability of getting all 20 right. Or, and hear me out, this is why the complement's such a big deal. It's the complement of at most 5. Oh, no, sorry, it wouldn't be 5 because it's more than 5. Milbrath made a typo there. Starts at 6 and moves on, okay? So, or it's going to be the complement of at most 5. And that's what I'm going to do. So it's going to be 1 minus binom CDF, 20 trials, 50% chance of success, 5 correct. There we go. Push some buttons. My seniors are already waiting on me. I dread them. 0.9793. Pretty good. But that's the odds of getting more than 5 right. It's probably going to happen. He gets 1 or less. So this would be the probability of getting nothing right plus the probability of getting only 1 right. That's it. Or you can just use the binom CDF. And we have 20 trials, 0.5, and we only going to get 1 or fewer correct, which is the easiest way to do this thing. If you can understand complements and the usefulness of binom CDF, and I actually don't need the 1 minus, I just need binom CDF. I don't need the complement idea. I just need straight up binom CDF. There you go. Teeny tiny thing. Same as we had earlier, right up there. Because that was the, all right, it makes sense to me. The reason it's doing this is because if you lay everything out, your probability distribution here looks like a bell curve. That's why it's doing it. So there's the notes that you couldn't hear. Hopefully you were able to hear them this time. Hopefully.